Hello everyone. In the last video we've seen how to actually use the inverse of a matrix to solve problems. To use the identity matrix for the Gaussian elimination to actually obtain the inverse of a function. And we have also seen a few examples, or just a couple of examples, on how that is done. You line up the identity matrix along the matrix that we have, and then you do the elementary operations, the Gaussian and Gauss elimination, to convert the matrix on the left hand side to become the identity matrix, and the identity matrix will be converted to be magically, as the content here says, it will magically be converted to the inverse of the matrix that we have at hand. Alright, we have seen a few examples and we've done a bit of operations on them, and we have also seen how to actually and how this actually makes sense, because if you have, say, A becomes the identity matrix because there's the identity matrix, and I becomes the inverse because I equals. Yeah, so that's how basically you get it. So because when you multiply I by its inverse, you get the identity matrix, and if you multiply the inverse by the identity, you get the original matrix, the inverse matrix. It's like you multiply by 1. That's basically it. And it becomes so it's like you multiply both ends by the inverse. Anyway, so we're supposed to do the exercises today, so let's get on with it. Find the inverse of the matrix using the elementary row operations. So first of all, we line the identity matrix next to it. So we have -3, -2, and then we have 7 and 4. So by lining the identity matrix, we have 1, 1, 0, 0. So before going or opting for this approach, the inverse directly should be easily concluded using the determinant. So 1 over the determinant multiplied by the matrix, and then inversing the right diagonal, and the left diagonal, and converting the signs on the right diagonal. And yeah, but let's stay with, we could also use the elementary row operations on this one. So we should have leading ones in the first row, and for that we will be dividing the first row by 3. So 1 over 3 out of 1 would be replaced by 1. In that sense, we will have so we will be multiplied by -3. In that sense, we will have 1, and then we have 2 over 3, and then we have 1 over -1 over 3. Then we also have a 0 on the other end, right? And now for the second row, we will also divide it by 7, and let's see. So we'll have 1, and then 4 over 7, and then we will have 0 and 1 over 7, and there we are. So now we need to have a 0 on the second row. So we will subtract the first row by the second one and replacing the second one. So we'll have 1, 2 over 3, and -1 over 3, and 0. So we will have a 0 here, 2 over 3. Let me convert these to fractions, and let me have my calculator up. So I'll have 2 divided by 3. That should be 0.7 or 0.66. Okay, so let's have this 0. Let's replace this by 0.66. And we also have we have 1 divided by 3. That should be 0.53. That's -0.33. Now let's do subtraction. We have 4 divided by 7, that should be 0.57. So this is 0.57, and then we'll have 1 divided by 7, that should be 0.142. 1.42. 0. You shouldn't get carried away with those mistakes. Now we should do the subtraction, sorry. So 0.66 subtracted, no, it's actually 0.57 subtracted from 0.66. Okay, it's a negative result there. So it's negative 0.09, and we will have 0 minus 0.33, we'll have a 0.33, and then we will have 0.142, and this is the result we have. Let me clean this up a little bit. It's quite nasty the way it's looking on paper. So we have negative 0.33, and then we have 0.33 and 0.142. Now, to have the identity matrix, we need to have 1 on the second row and 0 on the first row. Now let's do a 0 for the first row. So for the first row to suffice a 0, okay, so we will multiply the first row by 0.09 and the second row by and then we do a subtraction. So let's do that. We should not turn back. Now this is we got ourselves a bit of a hiccup there. So we can, no, we don't want to divide it by 0.66. What we can do is have the second one 0.09. If we multiply it by 0.66, let's see how it's done. Let's see the kind of operations it's done. So that's that. So that's the identity matrix for us. So add half the second row to the first row. So half the second row to the first row, half of it. Yeah, it would get a 0 here. And half, and then subtract 14 times. 14 times second row, yes, so that you would get a 7 and it gets a 0. So it's always better to work on the zeros first. And then you multiply the second by 2 divided by 4, and then you get that matrix. Using elementary row operations, just the same as we've done